So in this lesson, basically what's happening is you're going to have to use your reasoning skills, and you're going to have to persevere. You cannot just say, oh, that doesn't, it just, nothing works. Because note in the, up on the board, where in those homework problems that you have 5, 6 more, 11, 13 problems. It says only 2 are not factorable out of those 13. So you can't give up and say, for any more than 2 of them, they're just not factorable. Okay? But here's another thing students like to do. They like to give up too early and they only factor one time when they could probably factor another and maybe even another yet. So to factor a polynomial completely, this is where we're at. We're being able to factor completely. We do not quit too early. So we started this, we had a little prelim to it on Friday, remember, on the back of Friday's notes? When you factor, now you want to start looking at those factors and seeing if they can be factored some more, okay? So methods to factor polynomials, we just ran through them. The first thing I always want you doing now, from here on out, the first thing I always want you doing is looking to see if there is a GCF. If you can GCF it, you need to do that. Start there always. Number 1, say to yourself, is there a GCF for this? And then, when we have polynomials with 4 terms, what did we say we're going to do? What do we do with 4-term polynomials? Factor by grouping. Look for factoring by grouping. So in other words, can it be? Can all 4-term polynomials be factored by grouping? What do you think? You think they all can be? Did I ever say when I was teaching you it, if you have a 4-term polynomial, you can always factor it by grouping? No. I said you have to try to see if you can. We could, because that's what we were practicing. But that does not mean every 4-term polynomial will be factorable by grouping. Okay, well, what if we have binomials? What are we going to look for? What did we just most recent, which we didn't even review when we were running through them, what did we most recently do? What are we going to look for if we have binomials? You need again from me?
It's subtraction.
Okay, it's a special product. What are the binomial special products called? What are the special products for binomials called? This is what we want to look for. I'm not giving it away. I already got it. Sorry. It's only 3 ones. Difference of 2 squares. So we'll just call it, like I said, it is often said, just the difference of squares. We're going to look to see, do we have the difference? What does difference mean again in this situation?
Subtraction.
Subtraction. Well, it looks like it might have spaces for, maybe we could do the 2. Okay. Difference means subtraction. Squares means the beginning term and the ending term. The 2 terms of the binomial are perfect squares. And then if it's a trinomial, what are we going to try? We're going to try the diamond method. Or you can use guess and check if you want, but it's so much more efficient to use our diamond method. Now notice, these are things that we say when we look at them. Remember, what's the first thing you're always going to do though? No matter how many terms there are in the polynomial. I don't care how many there are. 2, 3, 4. What are you going to do first? Look for a GCF. If you can GCF it, you're going to GCF it first. And then you're going to look at it and say, okay, do I have a 2-term polynomial? Do I have a 3-term polynomial? Do I have a 4-term polynomial? And then from there, use one of these other methods. Okay, so what do you think you might want to do in number 1? Look for a GCF. Good job. What GCF do you think this one might have then? 3x. Okay. So we would GCF out of 3x.
It's a negative 3x.
Why do you want to use a negative?
Because the GCF's always going to be a negative with your first.
You want your first term to be what? In the new factor, you want it to be positive. So let's make that 3x negative so that we do have a positive first term when we divide negative 3x cubed by our GCF. So what is negative 3x cubed divided by negative 3x?
X cubed.
X, what?
Squared.
Squared, okay. Plus, what's a 27x divided by a negative 3x? Negative 9. So now, what's another way we could write x squared plus negative 9?
X squared minus 9.
Yeah, we could actually write this as, so let's just come back over here and let's write it as a subtraction problem because it's a binomial. So is that factor now also factorable? Yes or no?
Yeah.
Can we quit? Think we should quit yet? Say we're done? That's a what? X squared minus 9 is a what? Binomial with
Subtraction.
subtraction. It begins with
Positive.
a perfect square. Does it end with a perfect square?
Yeah.
Oh, well then this is what special product?
Difference of two.
Difference of 2 squares. So that means it's factorable, isn't it? Okay. So what would the square, so this negative 3x, remember we always arrow down so we don't forget it. And the square root of x squared is what?
X.
X. And the square root of 9 is 3. So that means we now have, maybe I shouldn't have arrowed down quite so far. I'm going to want to write on that line. We're going to have that GCF of negative 3x. And what are the two factors going to be for our binomial?
X plus 3, X minus 3.
X plus 3, X minus 3. Do you think we can do any more factoring? Okay, here's the thought process that needs to go through your head every time before you say you're done. Now we have a binomial right here, but it has addition. So does that factorable?
No.
No. We have another binomial here. It has subtraction. Is that factorable?
Yes.
Well, how do we know? We have to check to see if x is a perfect square and if 3 is a perfect square. No, they're not, are they? So that means we get to say we are done with this problem. This is the factored name, or completely factored name, for negative 3x cubed plus 27x. So a little reminder too that on Friday I said, what's the reason why we even have to learn how to completely factor a polynomial? Anybody remember what I said? What would be the reason? I mean, why? Is this just so that you can say, I know how to factor? Or what's the reason? Well, coming up in it, if not next year, for sure the next year in advanced algebra, if you are given an equation with this expression on one side of the equation, and maybe it is set equal to, I don't know, 0, let's say, and they ask you to solve that equation, right now, would you know how to solve negative 3x cubed plus 27x equals 0? Do you think you know how to solve that? What do you think? Yeah? Okay, what do you think the solution is?
Well, you could solve
What do you think, AJ?
If the ending product is 0, x, both x would be equal to 0. Because anything times 0 is 0.
Well, I will agree with you that anything times 0 is 0, but I won't say that both of them are going to be equal to 0. There's going to be one time where the solution, yes, x will equal 0. But guess what? There's 2 other solutions for that particular equation. So this is going to be important for you to be able to solve this type of equation. The solutions for an equation, if it was set equal to 0, would be 0, as AJ said. It would be negative 3, because what happens when you add negative 3 to positive 3? You get 0. So you'd have a 0 in here getting multiplied by those other guys. What would that create?
0.
0. And what would the other solution be then? What would make this one 0? Positive 3. So this has 3 solutions. It has a solution of 0, it has a solution of negative 3, it has a solution of positive 3 if it's set into an equation set equal to 0. So this is why it's important for you to be able to factor these polynomials because they will become parts of equations. Okay, you take a look at number 2 and tell me what you're going to do first. We better all have the same thought going through our head. Can I verbalize what should have gone through your head? Tell me. Can I GCF it? Okay, we can, huh? Okay, so then what's the GCF? 5y. Okay. What's the resulting factor?
Y squared minus 4y plus 4.
Okay. Are we done? What's your next thing you're supposed to think?
The diamond method.
Yeah, can I factor that new resulting factor? And it's a trinomial, so then we'd say to ourselves, can I use the diamond, I should try the diamond method, or is there anything else jumping out at anybody right now with that trinomial? Anything else that you're like, oh, that looks like? You're okay, well, I think you're gonna be like, oh yeah. Okay, so this is gonna come down, right? A equals 1, B equals negative 4, C equals 4. Oh good, this is just a 4, negative 4, 1. What are those two numbers? That multiply to 4 add up to negative
2.
Negative 2, negative 2. So that means that we can go directly to setting up the two binomial factors, and they will both start with what?
Y.
Y. Yeah, in this case it's y's instead of x's. And they will both end with negative 2. Oh, that is a special product called a, so this trinomial is really a what? What is this called? Perfect square trinomial. Oh yeah. Well, if we don't recognize it, that's okay. The diamond method helps us out. And so now we have these guys that have to come down also. So we have that 5y. We have a y minus 2 twice. By the way, before we write that, maybe we better evaluate, can we, this is a binomial with subtraction. Can it be factored again? No, because why? They're not perfect squares, are they? Okay, so this is our final answer, isn't it? So, oftentimes, you will not be done when you only have 2 factors. Trust me, you're going to be able to work harder and need to work harder. So you're ready for that checkup quiz tomorrow also. Questions? Okay, then let's go to the back side. By the way, before we do, I have to bring something up that I don't want to possibly happen, because this is what you do instead with this problem, which, by the way, you would not be wrong if you did this. Hold out a GCF of 3x, and you got negative x squared minus or plus 9. But what can we do with that? That 3x can stay 3x, but can I write this? Can these two trade places? 9 and the negative x squared?
Yeah.
And then it could be written 9 minus x squared?
Yeah.
Is this still a special product? It still has subtraction, doesn't it?
Yeah.
Is 9 a perfect square?
Yeah.
Is x squared a perfect square?
Yeah.
Well, then that's still factorable, isn't it? So our factors are going to look a little bit different. We would end up with positive 3x, and we would end up with 3 plus x, and 3 minus x. That's okay. That's okay. So again, don't give up too early just because you're like, oh, that doesn't start with a perfect square. Negative x squared can't be, I can't take the square root of that. Then you better think about something else you can possibly do, okay? Okay, now we'll go to the back side and see what we're gonna do. Well, hope your paper's turning over better than mine is. Okay. First move, find the GCF. Yeah, does every polynomial have a GCF?
No.
No, but do we have to check to see if it does?
Yes.
Yes. Okay, so this one does, we're gonna just put up here, no GCF. You know what, we don't want to think that that means we could, but that does not mean we get to quit. That means we still have to try. It might be a not factorable one, but we don't know until we try, right? So what are we going to try?
The diamond method.
The diamond method, this is a trinomial. Is it a perfect square trinomial? Come on, let's try and save ourselves some work. Oh darn, okay. A equals 2, that darn 2 is not a perfect square. B equals 11, well, nor is the C a perfect square, so no special product going on here. And this one we do 2 times 6, right? And we need a 12. We need a product of 12 and a sum of 11. Multiply. Well, first of all, they both have to be positive, both have to be negative, one of each. They both got to be positive, because they got to multiply to be positive, they have to add up to be positive. Well, let's think of the factors of 12. 1 and 12. They don't add up to 11. 2 and
6.
they don't add up to 11. 3 and 4. They don't add up to 11. What's that tell us? Not factor. We can't factor. There is nothing that multiplies to be 12, adds up to 11, so we would say this one is not factorable. You better figure out some other way to solve this one if it's in an equation. Okay, but you have to show me something like that, like you tried, okay? We did try, didn't we?
Yeah.
Okay. How about the next one?
It's not a factor,
It's not factorable. Why not?
because it's x cubed.
And you can't square 98 and you get 50.
Well, I think you all forgot something. Already? Are you kidding me? What's the first thing we have to look for?
GCF.
A GCF. So you're telling me there's no GCF for this? I so disagree. First of all, 98 and 50 are both even numbers. Tell me what goes into an even number for sure. 2. So I've already found at least something that goes into them both, so don't tell me that there is not a GCF. Okay, well, what do you think? Is 2 the best there is? You think so? I think so too. But how about any variable parts? Is there any variable parts to our GCF?
X.
Yeah, one has an x cubed, the other has an x, so they both have some x's. Oh, well that means then we're going to have to GCF this with a 2x. 98 divided by 2 is 49. Oh, you know, there's like a light bulb going off on my head. 49 is a perfect square. Ah. And x cubed divided by x is?
Another perfect square.
X squared, yeah. Huh. And 50 divided by 2 is?
20.
25. Yeah, well, we'll just do it as subtraction, sure. And
It's another
the x is gone, and oh, looky there.
perfect
How
square.
convenient.
Very
Very convenient, yeah. Okay, so is this a special product? It has subtraction. Binomial, perfect square. That means we're going to take the square root of 49x squared and get what? 7x. We're going to take the square root of 25y squared and get 5y, and we're gonna say, okay, well, that means now, I'm gonna go carried away with my arrow here. Okay, we need 2x to come down, we can't forget about that, fella. And we're going to have 2 more factors, they both are gonna begin with 7x. They're both going to end with 5y. Now what?
Adding one, subtracting.
Addition in one, subtraction in the other. Okay, now again, don't even think about quitting, but and by the way, when you're doing your homework, I would also like you to have out last Friday's notes, that back page, the back side. It's going to be very helpful also. Don't even think about quitting until you look at this and say, I have a binomial now. Does it have subtraction?
No.
Okay, then that's as good as it's going to get. How about this one? It has subtraction. Can we factor that some more?
No.
Is it a perfect square, begin with a perfect square? No, it doesn't. So we are going to say this is as good as we can get it. This is completely factored. Okay, you start the next one. First of all, why are you making it negative? The first term is positive. Let's only when the first term is negative do we probably just mess like that. Okay? And then is that the most number of innings you can take out of it? Okay. You got this, Austin? Will you open do it for me, please, while I'm checking the
The answer is short.
show everything you did on it for me, please. Because we're recording this too, so there's people counting on us. I can't be here today. Instead of 3, cute. So you still have to do A's in every term there. Do you think that's super cute? You don't want to have to do anything like that, it's still be behind it out. Oh, I see. Don't you have to do A's? Not one of your factors, don't these become A's? In a four-term model. Yeah. Remember, it skips sometimes with the pens, you might want to use your finger estimate.
Oh,
Okay, you gotta keep working, you got a trinomial now, you gotta try and factor that trinomial. You don't get to quit. According to Austin up here, this trinomial is factorable, so. So again, remember when you're done, don't circle that answer until you're certain you're done. You cannot factor any of those new factors. Oh, I think we've forgotten how to do the, when A is equal to 2. After you find those numbers, remember those become A's. You know what, you guys might have to have a, excuse me, all your notes when you're doing some of these, because, you know, you haven't been doing this for very long yet, so you don't really maybe remember everything. Okay, so after Austin factored out his GCF of 3a to the 4th, he had the trinomial 2a squared minus a minus 3. Do we all agree with that? You have the same trinomial? Okay. Well then, after identifying a, b, and c and setting up the diamond, he got -3 and -2 as the two side numbers. What do those become? They actually become A's, right? They replace that -1A. So here's where he has them right here. But he should have a plus sign between here. Okay? Those, if they're backed up like that, that looks like multiplication. And right now you just have made it into a 4-term polynomial is all. So we have two groups. And so he did the factoring by grouping. And by the way, even if you didn't put it in the same order that Austin did, if you did 2A squared plus a -3A, anybody do that? You should still end up with the same factors in the end. Did you end up with the same factors in the end, Gavin? Yes. So it doesn't matter which order we put these fellas in, but I'm guessing that Austin put them in that order. Why?
Because it'd be easier to factor.
Yeah, it'd be easier to factor them with the factoring by grouping. He thought, you know what? I want 2's together and I want 3's together, right? So the final factored name, I'm just going to take it away from the busyness up there, 2A minus 3A plus 1. Is that your final factored name? There's addition in this binomial. Can it be factored anymore then?
No.
Okay, there's subtraction in this binomial. Don't we have to check to see if it can be factored? Can it be? No. Okay. So again, you've learned a lot of different things about factoring. Now you're just going to pull it all together and say, what can I do? How do I do it? So that you can arrive at a good, completely factored name. Anybody want to ask questions of Austin or me? Okay. Number 6 is going to be like the one on the back, the last one we did in our notes on Friday. In the end, it should have more than 3 factors. Okay? So is there a GCF in number 6?
Yeah.
What would it be?
XY.
Just xy. The first term only has one y factor. The second term only has one x factor, so that's the best we can do for a GCF, even though there's all kinds of variable factors going on here. So what is xy, x to the 5th y divided by xy, class?
Excellent.
X to the 4th. Bring down our subtraction sign. What do we have for the other term? What's x? Y to the 4th. The x's divide out, don't they? Just like the y's divided out in the first term. Okay. Don't want to forget about that xy. I'll tell you what, if you go wrong anywhere, that's where it's going to be. You're going to forget about that GCF because is this one still factorable?
Yeah.
What is x to the 4th minus y to the 4th called?
Special.
It's a special product called what? Difference of squares. Difference of squares. So now we have to take that and say, what is this going to factor to? So what is the square root of x to the 4th power?
X squared.
X squared. What's the square root of y to the 4th power?
X.
Y squared. Okay, so that means we're going to have the factors that begin with x squared and with y squared. Tell me more.
Additions and subtractions.
Addition and subtraction. Okay.
We can factor subtraction one more time.
Can we factor this one?
No.
No. Okay, so that one's just going to come down. How about this one? Can this be factored?
Yes.
Oh, yeah. So now we're going to take the square root of x squared and the square root of y squared, and what are we going to get for x and y? That means now we're going to have two factors that begin with x and with y. Tell me more.
Subtraction, addition.
Subtraction and addition. Okay. Subtraction. Can that one be factored again?
No.
Okay. Addition.
No.
Absolutely not. Okay. Here we go. xy. X squared plus y squared. X minus y x plus y. How did something so neat in the beginning become something like that?
You could keep that.
Because you could keep factoring, that's right. So, we cannot quit too early. So, if you would have been tempted to quit it right up here and only have these three factors, the GCF and then these guys, you would lose you some points on the checkout quiz tomorrow because you didn't notice that you had a special product going on there. Okay? Questions? Okay, go to work on your homework.